had a great time with the master's thesis, and I actually wrote it in English and did the intro in English and in Dutch, because I wanted to impress my then boyfriend. Well, my boyfriend.
Sorry. Much more important.
Maybe I wanted to impress my examiners a little bit, but I mostly was trying to impress my boyfriend, he was Dutch.
I can't think of any more human activity than conducting science experiments.
The game I play is a very interesting one. It's imagination in a tight straitjacket.
The beauty of a living thing is not the atoms that go into it, but the way those atoms are put together.
What I always think should be the basis of education is not answers, but questions. We should teach kids how to question.
Teaching at Western Sydney was fun.
Awesome.
All right, so lean close like this.
Yeah,
okay.
Yeah. We can, if you don't want to lean, we can move it closer to you.
No, I can.
And you can touch it as well. Like.
I just don't want to break your stuff.
Yeah, that's all right. Okay, it's not so fragile. Yeah.
All right.
They're pretty cheap mics too.
Yeah, but I've been talking with a friend of mine about doing some sort of blog or podcast for ages now, because we were just like, I really wish that there was better information getting out to students about career options and the world of possibilities around any science degree really, and as well as like the real conditions that are awaiting you if you do choose to go for a PhD.
It's funny you mentioned that, because that's probably one of the main. That camera's a bit lopsided, I think, isn't it? It looks a bit like. Maybe it is tilted. Yeah, that's one of the main reasons we started the podcast, actually.
Yeah.
Like two main reasons. One's to kind of break down this somewhat barrier that seems to be increasing in our current world between this public and researchers.
Yeah.
So that's probably one reason. But the other really big reason is when I was in my undergrad, and I started my undergrad going, I'm going to get the paper, I'm going to get a job. And then about halfway through, I'm like, I kind of like this research thing,
Yeah,
so,
yeah.
But then I had no idea. I had no idea how to approach a supervisor, what topics were out there. I had talking to that. I'm not even recording on mine yet, but anyway, sometimes we keep like little.
It's really good to meet up, because I definitely am a strong believer in trying to educate as many people as possible about sort of the reality of the situation. I mean, it is quite sad for some people because they really don't have any idea what they're getting into.
Yeah.
And it's if you inform people properly instead of kind of giving them an illusion of what's expected, they're much better prepared to face kind of the extreme situations around PhDs. And a lot of the people that I've seen crash the hardest were people who really had this very optimistic view of what science was and what their career was going to be. And they thought, I'll go through, I'll get my PhD, I'll go into a postdoc, they'll pay me. And they, and you think, then I can have a career, I can have a stable career, I can do research, I can do teaching, and maybe once in a while I'll have to write a grant. And they think that's what's waiting for them because that's what they've been told. And it's like, guys, that's not. Sorry, somebody really needs to tell you that there's the situation is very, very different.
Realistically, hardly anyone really makes it to that stage, do they?
Well, realistically, very few people make it through a PhD. And once you do get through a PhD, it actually doesn't help your chances of being hired at all. And that's the thing that really makes people just sometimes just devastated, because they invest. I mean, I've done astrophysics for over 15 years. And I'll always be an astrophysicist, but, I have realistic expectations of what's out there. And so it's kind of like, you want to share this information with people and be like, look, just so you know, if you do choose, like you personally want to get a PhD, go get a PhD. That's your choice, but do it for yourself.
Yeah, do it because you love it, not because you think being a doctor is going to get you a high-paying job.
Exactly, and not because you think it's going to get you a job in university, which it's not necessarily going to.
Yeah, that's going to be a tough struggle to get a job at university, especially a stable job where you're not on casual contracts.
Yes.
Like most people seem to be these days.
Yes, most people are on casual contracts, and it was a bit funny because it's like even if you do get a longer term contract, they're usually not permanent, and so it's only like a small fraction of a percent. So that's less than 1% of successful postdocs. That's people who've had PhDs and who've done successful postdocs. Less than 1% of those people are going to be able to get a job. There's not that many jobs available. And so you've got to think, well, what do you want to do? Do you really, really want to go for that? Beware that maybe there might not be anything available in your country.
You got to have a backup plan. And it could be moving overseas.
Yeah, exactly. Yeah. Like, do you need to move overseas? Do you need to get a second degree? Do you need to join up with a research team that's in Antarctica? There's all sorts of ways you can do it, but it's always a question of like, how much do you want to give up for this path? And, there are people who've done the equivalent of free postdocs for decades trying to make it work. And it's very sad. So it's just kind of like, have a realistic expectation when you go in. And then, I think that if you showed people in their first year of studies, kind of say, okay, science is very useful. It's great to be educated. There are a lot of things it can help you with, but be aware that this is, the job market currently, and the academic job market is very, very slim. The industrial job market is much higher. If you want a PhD, like that's your personal goal, like that's what you want, and you want it for yourself, go for it. Like that's your personal goal. You'll always have it. That's why I did it. But if you want it because you think you're going to get a lifetime career in a university, chances are you're going to be pretty disappointed. That's
unfortunately the reality of life. We're talking about the PhD.
We should probably get you to just introduce yourself.
Are
we being recorded?
Okay.
Are we actually being recorded? Because it doesn't look like we're getting
introduced
much
myself
volume
at all.
Sorry, Elaina, can you just give us 1 second?
Dude, that's recording.
That's recording, man.
Testing 1, 2, 3. Blab codes from
Servian. We just have to
Servian.
make sure we get right.
I think you know what it is. It's just a little bit. Sorry.
No, top one.
No, is it? Okay.
We're just having too much fun talking.
1, 2, 3. 1, 2, 3. If you could just introduce yourself, Elaina, that'd be great, and just a little bit about your position and what you're currently doing.
Yeah, of course. So, fortunately for me, I've been working on my introduction here at Servian.
Sorry.
Hi, I'm Dr. Elaina Hyde, and I'm a consultant here at Servian, downtown Sydney. I'm also an adjunct fellow at Western Sydney University. I like to say that I'm an astrophysicist by training and a consultant by trade, but I'm actually I am actually fully, as of last week, the Google Cloud Engineering instructor for Servian. So we're actually partners with Google now. And I've been certified as a full instructor for Google Cloud Engineering, which I couldn't have told you what that was 3 months ago, but I can now. So that's where I am. And it's great for me because for me it's all about discovery and learning. And I really love finding new things. So I'm an old Star Trek fan. I have Star Trek spaceship talks that are original series themed. I love telescopes because to me, they're spaceships, right? And I love discovering things that no one has seen before. I just love that idea. I've always thought, when I could found something that was so radically different, you could feel your brain sort of twisting 3 different ways in your skull when you're learning it. It's amazing. It's like, what is this, right? And that's why I came here, actually.
Really? What put you on the path of astronomy and astrophysics?
Yeah, so we don't have a lot of time, I think, but a long, long time ago in a land far, far away, I was in Oregon in the United States, and I was about 15, and I hadn't really had a lot of opportunity to study anything. My school wasn't terribly good. They basically didn't have beyond, I want to say, remedial algebra. So I literally didn't know my multiplication tables, and was getting like 200% in my math classes. It was quite silly. And I started looking around like, what can I do? Where can I go? How can I, what's my next step going to be, right? And so I was looking around at people who were doing a lot of manual labor working, and I was doing a lot of things like odd jobs and welding and building fences. And, the people who'd been doing this for a long time, they're really beat up, like really, really beat up. And my dad was an old hand at odd jobs and that kind of thing. And he's always, my arms and legs, it's so sore. And, you get the terrible, the claw hand arthritis. And you're just like, there's gotta be like a better thing to do. Like you don't want to be doing this when you're like 30 or 40. Yeah. And
so did you live in a small town or something?
Yeah, it was kind of a small town. So I went from a small town on the coast to a small town in the country, and there wasn't a lot of stuff around. There was a library, and it was small enough that I actually read every book they had. Like I read really fast.
Reminds me of Matilda, the Roald Dahl story. You read that story?
Oh yeah, I'm sure I must have. Yeah.
Yeah.
It's but it was quite small. So I'm looking around and I found I heard from my mom. She kept saying, just get out of here, go someplace. And a friend of hers had gone to community college. And so I was like, at 15, and so I was thinking, okay, well, if I can get a car, which you could just get with a learner's permit, I could get to the community college. And so I spent a long, long time working for very little money. Like I'm talking $4 an hour type of jobs. Wow. Come and do manual labor for $4 an hour. And I'm like, yeah, I'm 15, I can do that. Let's go. So I was in pretty good shape, which is the main disadvantage with the academia. But yeah, so I did. I started community college out at Mount Hood Community College in Oregon. It wasn't huge, but it was big enough to where I could walk in and I'd be like, whoa, what's all this, right? Like there were just classes all over. I could take anything I wanted to take. And so I started taking night classes, and I was taking a bunch of different sort of random ones that I just kind of picked out. And one of them was astronomy, and the instructor was really cool. He was this really passionate, interested person, and I've actually kept in contact with him to this day. Doug McCarty, great guy, passionate, interested guy, and he was the lead instructor for astronomy. He built up the planetarium at Mount Hood Community College, and he actually did it without even a master's degree. So just goes to show that, you don't necessarily need the degree if you really want to work in an area. But he was always very friendly and really let me volunteer a lot. And so I was, very very active. They did this great thing where they played the Monty Python Galaxy song when they spun around the planetarium. And if you ever get a chance to listen to the Galaxy song under some spinning stars, it's epic.
Right.
So that was basically my intro to astronomy right there.
Okay.
That's a couple of things are interesting there, because I found we've interviewed quite a few guests now, and the inspiration stories kind of come down to two main things. Sometimes it can be inspired by pop culture or books, which you probably got a little bit of as well. But the other one is the one you just mentioned, is a great teacher, someone who really inspired them early on. And also, just on the that point you raised about not having a degree, we recently interviewed James Ferguson, who works at the Garvan in bioinformatics, and he was the same. He dropped out of his undergraduate degree and pursued computer programming, and is now a researcher at the Garvan in biomedical science. So, yeah.
Sometimes you don't need that paper. You know?
No, and that's a good friend of mine. She dropped out in her first year of her PhD because she was really not happy with how it was going. And she actually turned it into a master's degree. She just said, "I'm stopping here. I'm not happy with this." And she left the PhD, left Australia, and now she's working for a major space agency in Europe. Oh, wow. And she's very happy, doing amazing, and that was the right choice for her. And I mean, there were people who were trying to pressure her into staying, saying, "Oh, you're almost halfway there. You can do it. Just stick it out." It's like, if you're not happy and it's not the right choice for you, maybe find another path. That's all right.
That's good advice. You shouldn't force yourself through something that ultimately gives you a lot of grief. We saw that you did a master's at the Max Planck Institute.
Yeah.
What was that master's of?
Yeah, well, so I don't always take my own advice.
Maybe these are lessons learned from experience.
Yeah, I mean, if you're like, oh, if I could go back in time, I'm like, well, if I actually could go back in time, like, I couldn't convince myself. I'm too stubborn, right? And I mean, being very, very stubborn has had some advantages, because I've been able to push through things that normally would not have been an option. Max Planck was an interesting case, because I just come out of 5 years in Arizona, and I'd been sort of just pushing my way forward without a real clear goal. So I'd done everything that I could find that was interesting. I'd been studying astronomy. I got involved in observing. I did planetary sciences. I did a lot of engineering. I got involved in optical engineering, and sort of did all these very different projects, everything from radio astronomy to building sub-millimeter preamplifiers. And I was looking at, like, okay, well, where do I go next? And I put out, did the usual thing. You put out a lot of applications, and you get a lot of them back. And Max Planck accepted me for 2 different programs. One was in radio astronomy, and the other was in X-ray astronomy. And the X-ray astronomy one was a bit more instrumentation. And so when I was looking at it, I thought, well, I've not really done pure instrumentation, and so I should go and do the one that I've never done before. And it ended up being much more, shall we say, I guess the nicest way to describe it was a little bit close-minded, because it was not a very flexible program, and the way that the program was managed tended to be rather severe, in the sense that, like, people didn't want to discuss anything, and I found that it was mostly just, you do your thing and report back. But a lot of things, like, that my data would get deleted, and my projects would get messed with, and technical things would get misplaced. And so no matter how hard I pushed at it, it really was pushing against a brick wall. And the brick wall was other people. And you will find that, sometimes you can just keep pushing yourself against the brick wall until you're dead because they're never going to move when there's a lot of them.
So how do you manage a situation like that?
Yeah, well, I kind of had to triage a bit. So I set my own sort of operating principles. I actually had my mom bring me a laptop from the US because Germany was the first time I'd ever actually gotten paid for science. Before, I'd always had a lot of odd jobs and a lot of extra work that I'd done to, keep myself in an apartment and, buy that $400 car, which actually ran forever, by the way. Like, seriously, like 20 years, 350,000 miles.
Wow. Got your money's worth then.
Oh, yeah. Yeah.
Sounds like me with my AB car. It takes you from place A to place B, and that's all it's good for.
Just never dies. Or never dies so badly that you can't piece it back together.
Yeah, exactly.
But so eventually I said, look, I will never be able to finish my project description if my data keeps getting deleted. So I had my mom bring me a laptop from the US, and I just stored everything locally on that machine. And so I did my entire project locally on a laptop that I still have, by the way, and it still works. It's got everything installed on it, but very old operating system. So yeah, I had her bring me that, and I finished the required paperwork for the degree, and basically started looking around, like, where can I go next? Because I'm not staying here. It's and I could have, because I did technically finish the degree requirements, so I could have gone on to a full PhD program in Germany if I had wanted to. But by that time, I'd had a bad cultural experience as well as a bad research experience, so I wasn't particularly motivated to stay. And I think it was also pretty unlucky because I just happened to run into some very unpleasant people, and you sort of get a snowball unluckiness, and everything is just, this is bad, And that happens. I sort of told my friend, there's if you take it over a long enough time span, it's kind of a conservation of luck. It's just, at some point, just a lot of bad stuff's going to happen, and you're just going to have to try to get through it the best you can. But I had met my future partner at that point, who lived in the Netherlands. And he was really wonderful, and only a few countries away. So I thought, well, maybe I can find something that would bring me back to astronomy, which was very inspirational, and telescopes, and you have a little bit of escapism as well, because you're looking out to the universe, you're far away from Earth and all its problems. And so I thought, let me get back to astrophysics. Let me just go ahead and do a plain ordinary astrophysics master's. It's going to be a designated program. And so I thought, well, if I can do it in the Netherlands, that would be awesome. I could be nearer to my partner and do fun things. That'd be great. So I went to the Netherlands and forgot all my German and learned Dutch, and and did exactly that. I sort of said, okay, reset time. And I definitely needed a reset at that point because I was there for 2.5 years, so I was pretty burned by the end of it.
It's interesting how lifestyle choices can be a big factor in where you go as well. And a lot of people probably forget that, focus just on the research and the science, but you've got to kind of live as well and have a life outside of science.
Absolutely, yeah. And that was one of my main points of advice that I give to people now, is it really is very important who you're working with and where you are. Because if you're in a place that is very hostile towards you, or if you're around people who are very hostile to you, that adds up. And you might think like, oh, it doesn't matter to me, I'll just do my thing and they'll leave me alone. But mostly it does matter, and it adds up over time, and it can really affect you in ways that you won't understand until you're in it. And then it's a case of mental survival, right? So you've got to be willing to say, look, this is unhealthy and I have to get out, which is fine. If somebody says that, you absolutely should make room for them to go where they need to go. And that's true. Like, I always try to do that as an instructor. If somebody is having a very hard time, they're in a very bad situation, a lot of times they won't be able to finish a course. And that's fine. That's, that is should be a reasonable thing to say, look, you need to go do what you need to do. Great. Try again next year if you want to. So it's it's strange to me that some people put a very hard restriction on things like that.
Maybe we should move on to the...
So for this master's, was it a master's by research or was it just coursework?
In Germany.
In the Netherlands.
In the Netherlands.
Because you said
So,
you did
yeah.
a Masters of Astrophysics at University of Amsterdam, right?
Yeah. So I did a bunch of bachelors in Arizona, and then I went to in Germany. I did the master's purely by research, so it was purely technical. I was building a testing device for what are called PNCCDs, and those are silicon devices that detect photons in the X-ray range, and it's quite nice because it's very detailed and precise work. And I'd actually done some silicon work on antimatter traps in Arizona, which were based off of sub-millimeter wave path guides. So I thought, oh, this is really cool. I can build something, and I love to build things, anything, wooden things, metal things, just building things, really fun. And so I was really concentrated on that task, and I built a system for them. But in Amsterdam, it was quite different because they had sort of a year of research, which consisted of theoretical physics exams, on sort of all different topics. So we covered everything from like galactic to atomic physics, and it was really nice to dive into the mathematical theory part of it. But we also had opportunity to go and look at and do mini research projects. So I did a small project in radio astronomy. I did a small project on exoplanets. I got to go to the Canary Islands, do some observing there. And you wrap it all up at the end with a great master's thesis. So you have been in this time been researching some topic, and the topic I picked was LMCX1.
What's that?
It is a really fun star.
Why is it so fun?
So LMCX1 is in the Large Magellanic Cloud. And the Large Magellanic Cloud is near the Milky Way. So the Milky Way...
It's a galaxy, right? So just there, for people who don't know.
It's a messed up galaxy. So the Milky Way galaxy is kind of like a big fried egg, and our sun sits in the white part and goes around and around. And outside of that fried egg Milky Way shape, there are other galaxies that are trying to sort of collide with us. And the Large Magellanic Cloud, or LMC, is one of those galaxies. It's pretty big. It's pretty bright. You can see it from the southern hemisphere, which I love about Australia.
Correct me if I'm wrong, but doesn't the southern hemisphere have the best night sky?
Ooh, that it is a hard. People always say it's the best, and I admit that it's very, very pretty. But nothing hits you quite like the night skies where you grew up. And
That's fair.
when I go back to the northern hemisphere, especially in like the spring or the fall, and you get that midnight sky, it's just a special feeling. And I think, Australia, I love the skies here. I love that there have been, eclipses and interesting things. I love to go out and see it, but the ones you grew up with...
You can't underestimate the power of nostalgia.
Exactly. It's a nostalgia. I still watch original series Star Trek, so...
But you're going back to this galaxy in the star?
Yes. Large Magellanic Cloud. Very cool system. So in the Large Magellanic Cloud, there was one X-ray source found, back in the 70s or something.
Sorry, really quickly. So X-ray,
X-ray.
For people who don't know,
Yeah.
we're not talking like X-ray where we look at bones. Well, I guess we kind of are. But we're talking about the electromagnetic spectrum, so wavelengths of light.
Exactly.
Yeah.
So normal stars give off light like we see from our sun. If it's really, really active, it might emit more high energy light. And X-rays are very, very high energy, and we can detect them with special telescopes. And so the first ever X-ray telescopes were launched above the Earth's atmosphere, so the X-rays wouldn't be blocked by atmospheric disruption. And they saw this really bright X-ray source in the Large Magellanic Cloud, and so they called it LMC X1. Big source, LMC. It's really, really bright. It's the brightest source there. And like, what is it? What is this doing, right? And so for years and years, people were trying to figure out what kind of system it was. And there was always talk of a theoretical companion star, maybe around a black hole, but it would have to be really big. And the LMC is very, very young, so it's full of big, bright stars. And it's hard to find a big bright star in a field of big bright stars. So it took them a while before they actually found the O star that was associated with that big X-ray system. And one of the things that I did was I said, okay, well, X-rays, fine, great, whatever. I'm done with X-rays. I already worked with their instruments. I'm going to look at the O star. So I'm going to look at this big, bright O star. And an O star is basically like our sun on mega super steroids. It's giant ball of hydrogen, a little bit of helium, super massive, and it's so massive that it can just burn really, really, really bright, really, really hot. And it's that extreme heat and the releasing of energy that is thought to actually help power the X-ray emission. And so the cool thing is that this black hole was formed as part of, we think, a two-star system. And so it's a puzzle. Like, how did this happen? How did this black hole get close to this massive O star without just destroying it? And how is it feeding this X-ray right now?
Right.
And
this black hole is inside this galaxy.
Yeah, so inside the LMC,
Yep.
you've got a big bunch of bright blue stars, right? Blue stars and gas all over. And that's what you see when you look up at the night sky. You see a fuzzy, blurry thing.
And these blue stars, they're the really high energy burning ones.
Yeah, exactly. And it's really cool because there's a lot of stuff going on in the LMC. But if you look at just LMC X1, what you've got is you'll see the big blue star, and the black hole is, very, very close to it. So the black hole is like, I can't remember the exact separation off the top of my head, but it's close enough to where it's closer than Earth is to our sun.
Oh, right.
So it's quite close by.
So why isn't the star falling into the black hole?
Yeah, so that's a good question. That was one of the things where, how is this working, right? So it's a stable system. The black hole's just far enough away, and if you have two stars orbiting each other, or two anythings, a black hole and another thing, they all have mass. And how massive they are determines how much material they can just suck into themselves. So the reason that the black hole doesn't just pull in the O star is the same reason that the sun doesn't just pull in the Earth. It's because it's just far enough away and it has a stable orbit. Okay. So they kind of hang out together. And what's happening is that the O star is feeding into the black hole system and powering not only the X-ray luminosity, but when you look at the gas around the system, you can actually see traces that every once in a while the energy builds up and there are jets. And you can't see the jets right now, but we can see where they've blasted little cones into the surrounding area around the star.
Are they blasting X-ray emissions, or what are they blasting?
So high energy plasma blast.
Sorry, is this coming out of the black hole, like
Yes.
Hawking radiation?
No, so it's coming out of the black hole like a fire hose. So what's happening is the radiation's coming in, and every once in a while it builds up enough to where, so when you have material coming into a black hole, it sort of spins around the outside, and that's called an accretion disk. And as that material spins, it's one of the most efficient energy transfers known to man. So this is one of the ideas for infinite energy.
So we're talking about like bang for your buck. So when we
Yeah.
burn fuel in a car, a certain amount of the energy is lost as heat and things like this.
Exactly.
So the accretion disk of these black holes is really energy efficient. Is what you're
Yes.
saying. Yeah.
Yes. So right now we have on Earth, we have solar power, we have gas power, we have nuclear power, and accretion disks around a black hole would outperform all of those by a large margin, because they release almost all their mass into energy. And so those energy photons are really, really high energy photons. So you get X-rays, but also other radiation as well. And that then shoots out from the area around the black hole and goes out in a direction and blasts the surrounding nebula. And so the nebula gets what we call ionized. It reacts with that energy, and you can get cool patterns and all sorts of interesting things happening. And so it's a really cool system to study, because there's all these different things happening. There's highly ionized regions of extremely high energy. There's traces of jet activity from the past. And the whole system, the black hole and the O star together, they're moving through space. And most things in space move around. But these are actually moving through space through a gassy nebula. And one of the questions that I was trying to look at was like, how does this work, right? So if this star is moving through gas, it has a chance to interact due to its movement. And it might actually create what's called a bow shock. And so if you have a boat and you're driving it through the water, you see the water part around the boat, right?
Right.
And this is the same idea. It's like you got a star and it's driving through the nebula with its velocity, and the nebula is parting around it. Right. And so I looked at that with my master's thesis, and actually proposed that the system is not only moving through the nebula and causing disturbance, but it's also got jets and also got these regions, and also we can actually see traces of this in the O star spectrum. So that's the lines that are emitted by the O star, which is really fun. And I had a great time with the master's thesis, and I actually wrote it in English and did the intro in English and in Dutch, because I wanted to impress my then boyfriend. Well, my boyfriend.
Sorry.
Much more important.
Maybe I wanted to impress my examiners a little bit, but I mostly was trying to impress my boyfriend, he was Dutch. So I thought, well, I know how to be impressive. I'll just do the intro in Dutch too. So that was great fun, and I actually had the data for that for years and years and years, until I finally published it last year.
Oh, awesome. I think I saw that on your Twitter. Right?
Yeah. Oh, I pinned it. It's I'm quite happy
cool.
with that.
Yeah.
So sometimes they take a while, but it was a really fun project. It was very rewarding. The people I were working with were very good, and so it really got me back on track, like in astrophysics, and also sort of mentally back on track. Once again, a sort of a believer in science and logic and all those geeky things.
We knew we would have this problem when we talked to you. We've been talking for so long now. We haven't even got to your PhD yet. So I don't know. Where do you want to take this? Do you want to maybe?
It's a shame because we have quite a bit to cover with you, but the time is kind of the issue, and because I have to go to work, unfortunately. So
yeah.
we have to,
but we can do this again sometime.
Yeah, I was hoping to do that. But let's. I just want to
talk about
Galaxies.
Yeah.
Because
can I give a little intro to this? I've been prepping it in my head, right? Because you mentioned before a young galaxy.
Yes.
Okay, and I know from doing that wonderful unit with you, Cosmos in Perspective at Western Sydney. If you're a Western Sydney student,
yes.
You've got to do that unit.
Yes, definitely do that unit.
Stars have a life cycle, right? So they live and die, they birth new stars. But it sounds to me like galaxies have a life cycle too.
Yes.
Maybe you could tell us just a little bit about that?
Yeah, so
And-
how different, so for the folks that don't know the life cycle of a star, when I talked to Ian, he said, you get these clouds forming and then they condense and then there's enough pressure and heat and then you get a spark and boom, you have a star. And then those stars explode and they cause other stars to be born. But how does that happen with a galaxy?
Yeah, so it's a little too bad we don't have time to talk about my PhD because
No, well, we do have we've got a few minutes. If you can do it in a few minutes.
So galaxies, I think the simplest thing to say is galaxies don't quite have a life cycle like stars do. Yeah. So stars are usually thought of as contained systems, right? Mm-hmm. And you have basically, you're exactly right. You have a ball of hydrogen in space that can, through slight gravitational instabilities, slowly start collapsing. And actually, at this point, I just want to remind everybody that a really cool discovery just came out from Australia in radio astronomy, where they detected a signal indicating that the behavior of the very largest stars in the early universe is not quite what we thought. So have a look on this because it is one of the coolest ideas that I've seen in a while. It was a very small radio telescope detector and very cool setup. So I highly recommend reading up on that. It's a little more history of the early universe, but also massive stars. So I definitely want to plug that for anybody who's interested in current events. But not to get too far afield, stars do generally live and die, right? If a star is close to another star, they can actually interact to the point where they collide, and they can, usually it's thought of as the more massive star pulls in the less massive star, or the more massive star steals material from the less massive star, or the more massive star can send material over to the less massive star in some scenarios. And so you can actually have things like stars that have been refreshed with new material, and they don't quite evolve in this super linear pattern. Now that's probably a better analogy to galaxies, because galaxies, as far as we can tell, have been around forever. If there was a time when we didn't have galaxies, we can't see it. It's theoretical, and it goes back to that discovery I mentioned earlier. Is thought that there were some first stars of the universe that were very massive. But as soon as you have got gravity and hydrogen, you're going to have grouping together into things that are like galaxies. As galaxies get older, they do tend to use up the gas that they have. But they can still collide with other galaxies. They can still interact. They're still traveling through space. And the universe is expanding, so eventually you might get to the point where there's nothing else for a galaxy to interact with. But it's not really happened quite yet. There are galaxies that are very isolated, and they have very little material left in them, but they still have stars. And as a galaxy uses up its gas and sort of all the bright blue stars burn out, you're left with more and more low mass stars. So you'd have a redder galaxy filled with low mass stars, but low mass stars live a really, really, really long time. And so you could have those low mass stars around for I'm not going to say the age of the universe, because I'm not sure if it's going to expand forever, but it depends on what we find out about this new dark matter discovery. So it's a little more complicated than galaxies just living and dying. It's more like galaxies interacting. So they're always interesting when they're interacting systems. So you have a galaxy that's a spiral interacting with some sort of weird shaped thing, and it forms tails and does funky things, and you get active galactic nuclei and strong energy bursts happening, and all sorts of really cool stuff. I mean, as the best example, of course, is at some point it's thought that the Andromeda Galaxy, one of our near neighbors, will come in and be absorbed by the Milky Way. And they say galactic collision, but it's more like galactic interaction because it's
The stuff's so far apart.
yeah,
anyway, isn't it? Yeah.
it's pretty unusual for actual stars to actually slam into each other just by accident. It really have to be an extreme circumstance for that to happen. So it's usually like they interact with everything they can interact with until they run out of stuff that's within their gravitational influence. And that doesn't happen very often. And you get things like in the local universe, we have what's called the local group, which is a group of galaxies that are all bound together. And even though the universe on average is expanding, our local group is still gravitationally bound. And so you get, and larger scales, and it gets a bit weird. So just don't think about it like a linear evolution would be my primary advice. And the big problem with astrophysics is that ages ago there was this sort of tuning fork diagram done that was meant to look like an evolutionary ladder from spiral to red elliptical galaxy.
Right. Was this Hubble's theory on how the galaxies evolved through these different shapes?
Yeah, exactly. And it's not quite that simple. So it's really one of those systems, like the more you look at it, the more complex it is. And it's a bit like human evolution, right? So it comes from, all sorts of systems combine and interact with each other, and over time they evolve. But living and dying for galaxies,
it's not so black and white.
Yeah, it's not so black and white, not so clear cut. A truly dead galaxy would be maybe the best thing I could think of would be a globular cluster, but even they are more complicated than we thought. And those are the little tiny spherical groups of stars that orbit around the Milky Way, and they're quite old. And thought to be, at one point, people thought they were single population objects. But now we know better.
Maybe just one final question.
Wait, before you go on to that
You
final
got time?
question. Yeah, well, I just, because I have to pick up someone as well and take them to Campbelltown. But I've told it to me that Granville, so we should have a bit more time. You said that when we look in the far distance with our telescopes, as far as we can see back in time.
Yes.
Right? We don't see stars, but we just see galaxies, and we can't see anything before that?
Oh, well, so the reason we don't see stars is because they're really, really small compared to galaxies, right?
So they're not bright enough.
Yeah, it's like if you saw like a car from really far away, it would look like a point of light. And as it got closer, you'd see that it was 2 points of light, and it was headlights. And as it got closer, you'd see that the headlights actually had some space between them. And so galaxies are a bit like that, but instead of 2 points of light, it's like billions of points of light, and they're all squished together. So the first people that saw galaxies thought they were sort of clouds, maybe some sort of clouds in the sky, because they couldn't make out the individual points that were the stars. There are some stars that are occasionally very bright. Cepheid variable stars have been used for nearby galaxies, but the farther away you go, the smaller those stars are going to be in respect to their host galaxies. And so you're just going to see kind of a blur until we get better telescopes. So more telescopes in space is what I'd like to sell to you guys.
Awesome. Maybe we can really quickly just move on, because we've got to get to where you currently are now. How have the skills that you developed as a researcher in astronomy, how have they helped you where you are?
Yeah, so I think the thing that's helped me the most where I am is probably just the desire to learn has been a huge advantage, because there have been so many things that I did not know when I started out. I didn't know how data science and business were used in the quote-unquote real world. And I didn't know a lot of the basics around database warehousing and the terms that were used. And so just being willing to step into an environment and saying, I'm going to learn everything I can learn about this, and having that, being able to set up a curriculum so that I could learn it as fast as I needed to learn it. And of course, being able to set up a research project and carry it through, and knowing how to interact with other people who are also working on maybe similar or different research projects. So having those kind of basic research skills, I guess.
Yeah.
It's all very, very useful. But this is why I tell people, like, look, these are basic skills that you can pick up with any good research group. None of those necessarily need the degree.
Yeah.
So just don't equate those two things.
Yeah. It's the skills you learn in the degree and not the piece of paper itself that you're after. And you can get those skills by not even necessarily doing a degree, like you said.
Yeah, exactly. And it's what worked for me might not necessarily work for other people. But yeah, I mean, obviously having programming knowledge helps. And if you were to say, I want to learn a thing, I would say to you, learn to program in Python.
Okay.
That would be my if you wanted to go the learn a thing route.
Right, yeah.
Well, I did Java as a elective, and that was really fun. But is Python, does it just have more utility when it comes to? Why is this not picking up? More utility when it comes to doing scientific research?
Yes.
Okay. Like that.
Back to the drawing board.
No,
It's
not.
useful. It's useful
Yeah.
to know different languages. I've programmed in so many languages I can't remember them all.
Yeah.
And the more you learn, the more it's easier to learn new languages as you need them. And you will find things where you're like, oh, I need Java for this, or I need Fortran 77.
Yeah.
And that goes for even the biologist, I'm guessing, too.
Oh,
the way biology is heading as well. So if you're a
Yes.
biologist listening to this, that's you too.
Yeah, and that is something I would say that being here at Servian, we see clients coming in from all areas of science. We've seen people from medical science come in. We've seen people from biology come in, from chemistry come in, and everyone's looking at how to process large amounts of data, and how do you get insights from that data that make sense, and that won't take you a week to run.
Last question, and I suppose
Because we've got to have some photos too.
we got to take some photos, and I got to make sure that I'm not late for the first class I teach. Otherwise, the unit coordinator might just kill me. So you've done some programming, and you have experience in that, and you've done astrophysics. What do you think do you see the field of AI coming into astrophysics?
Oh, absolutely. Absolutely. One of my pet projects at the moment is things that combine AI and citizen science projects. Because what is a human other than a rather advanced AI, right? And citizen science projects at the moment use humans as AIs. But advanced citizen science projects using things like Galaxy Zoo that you can go and click on, they also actually use AIs to test their humans. Yeah. So if you're if you're really interested in processing large amounts of data and interacting with complex sort of machine learning algorithms, I think at some point basic AI is really, really powerful. And I mean, it's very useful for business as well. They've got things now like the Google Dialogflow chatbots, which are pre-trained to converse with people on a large amount of subjects, and it's actually amazing. I built one yesterday in like 10 minutes. It wasn't very smart, but I started teaching it to respond to astronomy questions. So it's getting much easier. The barrier for programming is going down, and I think the flexibility is getting much higher. And the AI pillar is the newest one here at Servian, because they're realizing just how useful it is. And not everybody needs an AI, but I think a lot of people will want to use them, especially if you provide pre-trained AIs. And I've seen a lot of people setting up pre-trained AIs for specific tasks, like for business flow processing or for your data analysis, maybe, for example. So AI is thumbs up.
Well, it's been a great conversation.
Yeah. It's a shame that we had to cut it short. Otherwise, we would have sat here for another 30 minutes talking to you, Elaina. But we've been talking for about 51 minutes so far.
Yeah, I don't think we have the room much longer.
Yeah.
So,
well, we might have to have you on again and talk
Absolutely.
about some of your other interests.
Yeah, and
we'll talk about the PhD sometime.
Yeah, we're talking about the PhD and some more astrophysics stuff. But thank you for being on the podcast.
Thank you.
All right.